Let's try another example. Okay. So now we have h of x equal to x plus 2 all over x squared minus 4x minus 12. To find the domain, we first need to find our restricted values. Take our denominator, set it equal to 0, and solve. Here you would be looking for a product of negative 12 and a sum of negative 4, which means that we would need x minus 6 times x plus 2 equal to 0. We find out x equal to 6 and x equal to negative 2 are our restricted values. You could have used the quadratic formula, but here in a moment, you'll see why you always want to try to factor. It saves you work in the long run. For our domain, remember negative infinity on the left, positive infinity on the right. And even though we found the 6 first, it's positive. It goes on the right-hand side next to the positive infinity, while our negative goes near our negative infinity. Setting up our domain, working from left to right. Remember, we always start on the left side. We have negative infinity to negative 2, union. Negative 2 to 6, union, 6 to infinity. Remember, the unions are the jump ropes where we're jumping from one section to the next. So we've found our domain. Now we can find h of x in simplified form. And this is why I said, go ahead and find your factored form of your denominator. Because when we rewrite h of x, we have x plus 2 up top. And in the bottom, we said that factored into x minus 6 times x plus 2. Here, the x plus 2's take each other out. Remember, what happens in the denominator stays in the denominator. So the x minus 6 stays in the bottom, 1 is up top. So we have h of x equal to 1 all over x minus 6. And this is why we find the domain before we simplify. If you were trying to find the domain now, you would only find x equal to 6. The x equal to negative 2 completely disappeared. So for our vertical asymptotes, it's what's left in the denominator. So we take x minus 6 equal to 0, which means that x equal to 6 is our vertical asymptote. Remember, the wholes come from canceling. You get a whole, and from canceling, we cancel the wholes. Okay? Since we canceled x plus 2, set it equal to 0. We get x is equal to negative 2. So we have a whole at x equal to negative 2. Notice our restricted values were 6 and negative 2. Your restricted values are always going to be either vertical asymptotes or wholes. But let's say that you're asked to find the coordinates or the point where there is a hole. If we have the x value, we're going to plug in our x value to the simplified h of x. Once you simplify your function, never look back. Always use the simplified form, because once you simplify your life, you're not going back to that craziness. So h of -2 will be 1 all over -2 minus 6. 1 all over -8 gets us -1/8. So if it just asks us where the whole is and what's the x value, we would say at -2. But the coordinates of the whole are at the ordered pair -2, that was our x value, -1/8, which was the y value we got out. Okay. For our horizontal asymptote, remember we're looking at our simplified version. Once you simplify, don't go back. Here, the degree of our numerator is 0 because there are no variables in the numerator. The degree of the denominator is 1. That's because there's the imaginary 1 hanging out on the x, which means the denominator is bigger. When your denominator is bigger, you bottom out. So we have a horizontal asymptote of y equal to 0. Bottom out, we go to 0. Let's find some intercepts. The first one we're going to look at is our y-intercept, which means that we are going to plug in x equal to 0, and we're going to do that in our simplified version. So h of 0 is equal to 1 all over 0 minus x, minus 6. 1 all over -6 gets us -1/6. Our y-intercept is the ordered pair 0, since we plugged that in for x, -1/6. Remember, for our x-intercepts, we plug in y equal to 0. But that also means that we set our equation equal to 0. So set our equation 1 all over x minus 6 equal to 0. But remember when I said we could multiply by the denominator to clear it out? So we're only looking at the numerator equal to 0. And we have 1 equal to 0. 1 is never going to equal 0. And because we don't have anything to solve for, that means that we have no x-intercepts. And that happens quite frequently when your horizontal asymptote is y equal to 0.